Hello, everyone. Thank you for joining the last session of today, which is Lightning Talks, and we have 1, 2, 3, 4, 5 plus 1 extra Lightning Talk, which is the end of the contest, which isn't written here but will be here. But we have 5 awesome Lightning Talks today prepared. And now, first of all, a little bit of rules how Lightning Talks work. A question: how many of you have already been to a Lightning Talk session in Slovakia or somewhere else? Okay, most hands up. So the first rule is 5 minutes max. So we have a timer, and this timer is strict. Once the timer falls down to 5 seconds, I will show you, but you can start clapping just with your fingers. So let's try it out. Yeah, awesome. And then once the timer falls down to 0, we give the speaker a round of applause, and then we will wait for the next speaker to come and connect his computer. Any questions? No. Okay, so can we start the timer? And now the stage is yours.
Okay, PRO and Parquet format for big data. Big data is, for me, everything what is more than 100 gigabytes, terabytes. For example, in our company, when we are working with big data that is like 1 to 2 terabytes tables with our storage is like 5 petabytes when we are using this data for machine learning. And PRO and Parquet is a really good choice for storing the data. Before, it was, you had some data format, CSV, JSON, or whatever, and then you need to convert it. But with Arrow, you can one memory format, which you can use and basically use that format in many tools. Big advantages for machine learning is when you are using Parquet with Arrow, you can basically move the data without zero copy. Even when you are shipping data to GPU, NVIDIA is working on great support for moving the data without wasting time on copying the data. Basically how Arrow is working, you have storage, what can be S3 or whatever, memory, and then you have API for C++, Python, and yeah. The biggest advantage is zero copy and columnar format. Parquet format is divided to row groups when you have data store in columns. Every row group have metadata, and basically this you can use for pushing down the filters to the files. Metadata contain statistics, highest value, lowest value. For example, when you are like filtering the data based on the value, you see there is like not value in this column and you can skip it and basically go to row group which you need for your loading. When you are using, for example, pandas, you can define a panda data frame and directly convert it to Arrow table and then save it. When you are loading the data, you usually use dataset, or you can use Parquet Reader directly. The metadata you can see on the top. Basically, you see there number of row groups, which is usually about 100 something megabytes, and group rows. Down there you can see schema. Based on that schema, data are stored. When you have big data, you can divide them to multiple partitions, and here is interesting things. Basically, PRO is supporting FSPEC, and sometimes partition schema is not good for, I don't know, Dask data frame or something else, when you cannot use multi-index for filtering, then you can use fsspec, create virtual file system, and put it directly to dataset for filtering. That way you can filter the data if you have metadata, for example, in database. And you can really speed up the loading and processing the data. Filtering in a dataset is basically using expression, and if you are combining it with Parquet files, reader is using metadata and filtering the data, basically reading just what you need. And this way, you can basically load a lot of data fast and ship it to GPU for machine learning or for something else.
Awesome. Thank you for your talk on Pyro. And the next speaker is, yeah, you didn't write your name here?
Yeah, no.
Okay,
Sorry.
and I'm sorry, I will not try to pronounce your name because, yeah, but we'll connect you the computer. Fallen asleep. Okay, so now we're going to have a talk on, is that PyRead-once? Okay, and can you just pronounce your name? Sorry.
For the ease your pain is Shako.
Okay, where are you from?
I live in Berlin. I'm from Azerbaijan. I live in Berlin, originated Azerbaijan.
Okay, and yeah. Browser. Yeah, it's yours. So now, as you can see, lightning talks don't have to be big presentations. They can be short, and they can be even shorter. Now we had one almost 5 minutes long, but I've been to some awesome lightning talks in the past, either at our conference or other conference, where it took only 1 or 2 or 3 minutes for the speaker to convey a really, really awesome message. So if you're planning to do a lightning talk tomorrow, so don't be afraid of the time, 5 minutes, you don't have to use it. Whole, and also it doesn't have to be only about Python. I think personally one of my favorite lightning talks at PyCon Slovakia was how to use sticky notes and how to tier sticky notes so that you don't bend them. If you want the link for this lightning talk, I can send it to you. It's one of my favorite ones. Okay, so are we set up?
Yeah.
Okay, awesome. So let's start the timer, and the stage is yours.
Yeah, thanks for coming. We are going to talk about the read-once objects, and it's a concept related to the security. And I'm, as a software engineer, just part of work related to the security. So what is read-once objects? There is a wonderful book about secure, it's named Secure by Design. And the read-once object is something that you want to protect some part of your application which is sensitive. And you want to limit the access to this object. And so this library is mine, and you can go and if you want to open a pull request or test it. So basically, the read-once object is something that cannot be subclassed, cannot be serialized, or cannot be accessed twice and others. So let's just go through the README, and we will understand. So just pip install the read-once, and then you create a password object, and just ordinary Python class inherited from the read-once. Then suddenly somebody tries to dir your object, and like it has a guard on that. It just returns back an empty list. Even the dunderdict cannot be accessible for this object. It's going to return back again empty dictionary. If you one time gets a secret back, second time it's unsupported, so not allowed. It's just one time. So that's what is called a read-once. Yeah, it can be accessed only once. The secondly approach for the attack scenario, you can get an object and try to add your own secret back to get all of the secrets, like smuggling the response. But here it's prevented if the kind of attacker injects a new fake it should be data. So injects new fake password. It's gonna get back only its own password. Then read-once object cannot be subclass. This is the kind of attack you want if you want to prevail the superclass fields. The easiest thing that you can subclass it and dump the parent class fields. So subclassing is not supported. The accessing directly the secret object is not supported. So this is an ordinary field lookup. This one is accessing the protected members. So it's Python syntax to access the private members. This object cannot be pickled. So if somebody tries to dump your object, unsupported operation, it cannot be dumped. This object cannot be JSON serialized, so it cannot be serialized and deserialized. Even with custom encoder, you cannot do it, so it's prevented there. If you have, for example, custom password encoder to bypass the Python's built-in JSON encoder, it's gonna be, one more time failed. But we do not stop. This, attack vectors are getting to the YAML, JSON, pickle, and for read-once object, you cannot make it YAML, and it's not supported as well. There are cases where in the source code or in the logs, any kind of logs, accidentally somebody dumps the object. And this prevails to security like breach. And here, if you try to directly access the object or print the object, just masked, so cannot be dumped. How about Athers? The Athers is a wonderful library which you can use for yourself. This is supported with the data classes. Unfortunately, you cannot data class directly the DB password, but what you can do is create a different kind of sensitive information and then collect it inside one data class. Then, of course, it's gonna be work as usual. If you print the object of the data class, again, it's masked. This object has no getter at getSet, and you cannot bypass the descriptor side of the object. What else? For Pydantic, it has a support. Done.
Awesome. Thank you. So today we only have speakers who have perfect timing.
Yeah, thank you very much for listening.
Okay, thank you very much.
I can go.
Okay, and can I ask Juraj to tell us what is random? Okay, do you have your own computer or? Okay. Okay. Okay, so what is random? Are you set? So, okay. Okay, so stage is yours.
Okay, welcome. I really thank you came, but we will ask the question, what is random? What the first thing you imagine when you say random? Say it out loud. Okay, to me, it's coin flip. A coin flip is more likely a 50-50. No, it isn't, because if I know which force I use, the fraction of the air, and so on, I know definitely what the outcome will be. And it's a special case, sorry. The coin lands in like this. I cannot get it, but you get it. It is possible. It is like 1 on 6,000, but it's possible. So coin flip isn't random. So what is? If you say it like that, random isn't anything, because we have gravity forces which are constant. And like that, we cannot have random things. If you know everything, every force, every little thing in the universe, every atom, you can predict everything. So, about us. What does it say about us? We are random or aren't? I think we aren't random, because when we say, wow, this guy is so random, it isn't random. It was, I am here, I'm not random, I choose to be here, so I'm not a random. To you, I am maybe a random person. I am not. I have a name, I have a person, so I'm not random, and you are, and you aren't too, because since I don't since I don't know you, maybe you are random, but you aren't. To someone, you aren't random. So, what is random? Like I said, anything is random, because universe. But yeah, that's all I can say. So, like, in summary, there isn't anything like a random thing. So please don't use it random on something like, wow, this person is so random. There isn't. They're just behaving weird. That's the case. You can say, wow, this person is weird. That's it, please. Thank you.
Awesome, thanks. Thank you. Can I ask the next speaker to prepare his talk, GenAI for tabular data? Mike? And we'll have a computer, okay. Okay, and just in the meantime, to find out how many Python programmers are in this room, who thought of random initer as the first thing when the speaker asked about what is the first thing that you think of when random comes to mind? Randint, yes, randint, random initer. Sorry. Yes? Yes? Yeah, you still have time, of course. Yeah. As you are saying, computers are usually pseudo-random, not random. You wouldn't probably want random stuff happening around your computer, so that's why they have to generate something that seems random, but usually isn't random. So even randint isn't actually random, it's just pseudo-random, and probably someone can make a lightning talk about that, how the seeds start. So are we ready? Okay, awesome. So the stage is yours.
All right, let me start with a couple of questions. Who is familiar with synthetic data? Oh, a couple of people. How about structured tabular synthetic data? 1, 2, 3. Okay, nice. So I'll go a bit into that topic, and let me present the way we can very easily do it using Mostly AI platform, and that's actually where I work, which is a startup based in the neighboring capital. But anyway, let me just go through this simple notebook. Basically what I'm doing is first I'm installing Mostly AI package, importing it, giving it an API key, and now I'm opening just not a random but census data, and it looks pretty much like this. Now, I actually already pre-trained it, so there's actually some machine learning involved behind it, along with some other data processing and all that stuff, which essentially gives me the option to generate a synthetic data set which is based on the real one, but is absolutely privacy preserving, and at the same time, it retains practically the same statistical representations. So let me show how it looks like. So after training it and generating, you could see that it looks very similar. Probably not random, but absolutely synthetic identities. Let me show another quick example of using some excerpt of data of Airbnb for London. So first of all, it looks like this. So we have host, title, property, room type, neighborhood, and price. But this time we actually also want to program the data a little bit. So I already pre-trained this one because it takes a little bit longer, definitely more than the time that I have in this lightning talk. And I actually want to specify some particular seeds, so it's more or less like a context. I want to say, hey, I want to create a data frame which is centered just around Camden neighborhood. And I have 3 different room types, each one 5 times. And I want to generate data based on that with retaining all the same statistics. So let's do it. So it will run for probably about half a minute. And after that, we can see the results and see if it makes sense. What we're seeing here, by the way, is just very simple examples for one table, but there are also the options of doing it for a whole database. Anyway, just to see this quick example, I sorted it by price, and what we're seeing is completely synthetic entries that, as we could see, are probably quite representative. So we see that typically the shared rooms and then private rooms, they go pretty much hand in hand with the increment of the price. And also usually the titles make more or less sense, but all in all, it's just based on the data that it was trained upon. Thank you very much.
Thank you. So, and now we have our last lightning talk speaker. Well, it sets up. One more thing I remembered about the random. We talked during the last break that computers aren't random, and I've read an article about a big study conducted on tens of thousands of students, which were coin flipping like mad, and turns out that even coin flips aren't entirely random. And I'm not just talking about the special edge case where the coin lands on its edge, but even when you flip it, I think there's something like 50 point something 5% chance that it lands on the side on how you started flipping it. And there's a big study, and I think thousands of students somewhere in America were coin flipping to prove this hypothesis, and it is probably true. It was a big study conducted in America, so you could argue with it. And are we ready?
Super. Okay. So there are.
Can we go? Okay, so stage is yours.
Thank you. There are many ways of finding prime numbers, but has anyone done it already using regular expressions? I have 4.5 minutes to do it, and I'm going to live code because what could probably go wrong, nah? So first, in this standard Python 3.11, I'm going to import RE and then write something that for x in range, I'm going to cheat, I'm going to start at 2. That's okay? Yes, and I'm going to find all prime numbers from 2 to 99. And then I have to find something. So if RE search the stir of x, well, if it ends with a 0, then it's not a probable, it's not. So I want to find the prime number, so I have to negate this, that's fine. So I have all the zeros, removed all the zeros. Let's also remove all the 5s, that's fine. Let's also remove all the 2s, 4s, 6, and 8s. That's even better, but there are still some things that we are missing, and we also get these 3 and 7, and we actually need the 2. The 2 and 5 are actually prime numbers, so we should actually test that this is not 2 digits, but we are on the right way. What can I do? I can also match something, but that match from the beginning. Full match is also from both ends. So if I do full match, And at the beginning, I expect I can remove this because the end is automatic. And now I will find anything, then I receive the same. And now, look, 2, 3, 4, that's fine, but I see the 4 and 6 and 8, they should be removed because there are no prime numbers. We have 2 minutes, 2.5 minutes. Any ideas?
Make it bigger.
Bigger? What bigger? The screen? Font? Okay, sorry. Then hopefully you are going to be able to help me, but, well, wait. Like this? Hey, but we lost some time. Can I have more 5 minutes or? No. Okay, so let's do it again. RE, and well, I hope I have it here already. Okay. Maybe I can take a shortcut. Maybe I could do something else. Maybe I could do something like this, and this, and this, and then do something like this, and this, and make this, and this, and? Thank you. I leave it to the reader to interpret this. Thank you.
Awesome. How far can you go with it? How big numbers?
Probably any number. Try it.
Okay. Okay.
Kurde. Masz HDMI-čko, czy chcesz C-čko?
Miseczko. Dobra. Okay, so now the last session you've been all waiting for. Who of you has participated in the contest for the Turkish speakers dinner? Okay. The question: who has participated in the contest to win the speakers dinner ticket? Okay, a few hands there. Okay, so that was the contest which I announced this morning at the conference opening, and it was the contest you could participate in at our community booth right in front of this auditorium. And can I just ask for the slides? Okay, any moment now. Awesome. So the concept was, the question was, how many teachers have went through our teacher training program, which our non-profit SPI or Solak Python user group, so that's the non-profit organizing PyCon, how many teachers have went through our teacher training? And you've got some wild numbers. Some of them were really large. We wish we would have that capacity to teach the teachers. Some of the smaller ones, but the exact number which we were looking for is 1,546 teachers which went through our teacher training courses last year. That was online courses, physical courses, online webinars, all kinds of activities. And these are teachers from Slovak primary and secondary schools. So quite a large number for us, and we're really proud of it. And of course, now the announcement of the 5 lucky people who guessed the numbers which were the closest. I think the closest one was around 1,000. So still far off by a few hundred, but yeah, the closest numbers and the other numbers were a little bit far off. So yeah, these 5 people just talk to either me or somebody at the cloakroom, and you can get your free conference ticket or the ticket to the speakers dinner, which will be tomorrow at I think it's 8 o'clock, hopefully, if I'm correctly. Yeah, some speakers are nodding, so yeah, 8 o'clock. It's good that the speakers know when the speakers dinner is, even if the organizer doesn't. So that's all. Thank you for attending PyCon Slovakia. This was the last session, if I'm correct, of the Lightning Talk. So Miros was the last session. This was the last announcement. Once again, if I can ask you for a round of applause for all of the Lightning Talk speakers. And yeah, hopefully see you tomorrow, and hopefully full of energy and prepared for a full day of talks. Thank you for coming.